okay? All right, let's see. How am I going to answer this question here? First of all, there's a couple of ways to go here. But let's talk about inverse functions. Okay?
Okay.
Anytime a function is an inverse function, then its range is whatever the domain was of the function. They merely interchange. In other words, the domain becomes the range and the range becomes the domain. So, if we look at a curve of tangent of x, we could go straight to inverse tangent, but most people have a hard enough time figuring out the curve of the tangent. And this is what it looks like. It's got asymptotes and goes from negative infinity to positive infinity. That is y equal tan of x. So let's examine that, okay? And then this repeats every pi. In other words, this actually looks like this. If you were to draw multiple cycles of it in both directions, it goes on to infinity. So when they say, what is the range of inverse tan? That's inverse tan. It's whatever the domain of tan is. Now, that asymptote is there. That asymptote is here. And we have an asymptote every pi. So that's what the tan x looks like. Now, first of all, it becomes difficult to describe the domain. You tell me what the domain of tan x is.
Be pi over 2, or no, negative pi over 2 to pi over 2.
Plus any multiple of pi. So maybe you would write that as minus pi over 2 to pi over 2 plus any multiple, which I could call k or I could call n, of pi over 2. In other words, notice that every one of these is a multiple. No, they're not. They're all multiples of pi. We don't need the 2 in this part. Hold on. In other words, every asymptote that I have drawn on my graph over here actually fits that right there. We don't even need this first part. In other words, if I'm trying to describe the domain of tan x, then it's pi over 2 plus, this means all the integers from negative infinity to positive infinity is what k means. And you'll notice that every one of these asymptotes, in this case, this first asymptote or that asymptote there is when k is 0. If k is minus 1, you get that asymptote there. If k is 2, you get that asymptote. If k is 1, you get that asymptote. So this is the terminology that is used to describe the domain of tan x. Now they're asking for the range of inverse tan x. Well, that's the same as the domain of tan x. And we can see that that does not fit any of the answers. Therefore, E has to be the answer. Do you have answers on these?
It's going to be on a different document. Let me find it.
Yeah, I don't mind you having that available. In fact, I would like you to be able to access it, but I would prefer you not to have it open while we're going through these. I don't want you to know the answer to these as we're working through them in advance.
Okay. Yeah, I don't have it open. I need to find it.
Well, that's okay. We don't need to. I'm 99% sure of my answer here. Sometimes I want confirmation just because I want confirmation. Well, just because I hate giving people the wrong information. So if I've made a mistake, I want to know about it. You know what I'm saying?
Yeah.
But one should be E. And you can have that document available to you so that you can check it whenever we get done with a problem. That's what I would suggest, but just don't have it open.
Okay.
Okay? Let's look at number 2.
I got the documents.
What?
I'll send it to you. I'll send it to you in another email.
Well, okay, you can do that if you want, so that I can open it up and look at it, and I'll check it on my end, which is really better. That way there's no way for you to know the answer in advance. Yeah, send it to me and then don't open it on your end.
Okay.
All right. All right. What do you think the answer is on 2? I'm still studying it, but I want to know how much of this you know.
Wouldn't it be B?
Very good. That's what I would say. In other words, you're tempted to say E, all real numbers. But if we look at just this part right here, we have to examine what the domain is of X. And that's the same as the range of sine of X. Well, the range of sine of X is 1 to -1, which makes that the domain of inverse sine of X. So the domain of that could be anything, but you got to start from the inside out. And X has to be, you can never take the inverse sine of a number greater than 1 or less than -1. In other words, if I tell you that the sine of X equals 1.1, that's impossible. Now, if I go to solve that, that means X is going to be the inverse sine of 1.1. And you cannot take inverse sines of numbers greater than 1 or less than -1. Therefore, this is the only answer that really works. Even though it would appear that it should be true for all real numbers, it's not, because they're talking about domains and ranges now. So we can expect that this is an odd, unique problem, where you would have to examine the domain and range from the inside out. Usually a person looks at that who is somewhat knowledgeable about trig and they say, yeah, that's true for all x. So it's easy to make a mistake here. I'll go back and examine the answers after I get through a few of these. And if I've made any mistakes, I will re-examine the problems and get back to you later on it. But for now, I'm just going to go ahead and go with my answer. And again, number 3 is a question about domain. Okay. So, how do I answer that? What's the first logical step that I want to answer?
What's the range of sine?
Correct.
Inverse sine 2x.
Not the inverse sine, the sine. What is the range of that? In other words, the range of that is going to be the same as the domain of that. Well, let's graph that. How do I graph sine of 2x? What's its maximum value? What's its minimum value? Because what I'm really interested in is the range, right? So I don't really care what x's domain is, but if I were to graph this chart, it actually looks like this. Where that's 1 and that's minus 1. In other words, this is a horizontal shrink factor. It's not vertical. It does not change the amplitude. It changes only the horizontal measurement, which means the range of that is still -1 to 1. Hold on. Okay. So that's the range of 2x. This is what we've graphed. Y equal sine of 2x. That's what that is. Okay? So we can say that the range of 2x has to be less than 1 and greater than, no, excuse me, less than -1 or greater than 1. And if you do the algebra here, you get x has to be greater than 1/2 or less than -1/2. There or equal. It's less than or equal. So that is the range of this. And therefore, it's the domain of the inverse of it. Which is E. Now, let's go a little bit further here and let's talk a little bit more about this, because this is an important concept. If I have this y equal sine of x, and I wish to talk about its inverse, I can't just reflect that over the line y equal x. I'm going to end up with something that's not a function. Since I want its inverse to be a function, I've got to restrict this domain. And it's restricted with the sine function. It's restricted from minus pi over 2 to plus pi over 2. In other words, this part of it right here. Oh man, hold on, let me use a better color than that. That part of it right there. So when you talk about inverse functions of trig functions, you can't even talk about them being functions unless you restrict the domain. So they do with sine. And because they restrict the domain from minus pi over 2 to pi over 2, it means when you're looking at y equals inverse sine, then the range is always minus pi over 2 to pi over 2. If you put this into your calculator, what kind of calculator do you have, Zach, this year? You got an Inspire, don't you? Yeah, sure.
Yeah.
If you put inverse sine and you put any number of degrees, it's going to give you an answer either in the fourth quadrant or the first quadrant. It does not give you the answers in the second and third quadrant. Even though they exist, in order to make this thing a function, they restrict it from minus pi over 2 to plus pi over 2. Now, whether that affects this problem or not, I don't think so. I just wanted to make you aware that they do restrict the domain of the inverse sine function. The domain of the inverse sine function. Ooh, so let's see. Maybe I got this wrong. If the inverse sine function is restricted to that, then what is inverse sine of 2x? Well, it looks to me like it should go from minus pi to pi. If I multiplied both of these numbers by 2, that's not an answer on there. Hold on a second. If I'm going from minus pi over 2 to pi over 2, then 2x would go from minus pi to pi if I was doing it this way. Hold on, I need to check the answer on this one, just because I need to know whether or not they are restricting the domain from the get-go. What problem is that? Number what?
I think it was 4.
Okay.
No, it was 3.
It was 3. All right. As long as we're looking at the answers, let's review our document. All right. Let's check all 3 answers. What was the range of that? I said none of those, right? So A, I said E. Oh, you kidding me? Which test are we on? Test 4.
4, yeah.
So the answer is D for A? All right, let's go back and talk about this because I think I know why. In other words, that is also restricted. If you draw the tangent curve, and you reflect that, the domain of that is minus pi over 2 to pi over 2. All right, you know what? I don't agree with their answer. really don't. I don't know how they can put that answer up there in good conscience. Because this is what the domain is. Now maybe they just haven't gotten into this. But the tangent curve repeats every pi. So its domain is not minus pi over 2 to pi over 2. Its domain is pi over 2 plus k pi, where k represents all integers from negative infinity to infinity. Now, it's possible they haven't gotten to this yet. Have you ever come across this yet? Whether it's a k or an n, doesn't really matter.
Not in this class, no, but I remember like last year we did.
Okay. So, had you never been taught this, then you would look at the tangent curve as going, the domain goes from minus pi over 2 to pi over 2. And they're saying that's the range of the inverse. Well, I beg to differ, but it isn't. But nonetheless, they said the answer was D. Do you have an actual professor that you can talk to?
Yeah.
Well, this might be one that you might want to talk to him about. And if you understand the way I explained it to you, then you could explain to him why the range is not minus pi over 2 to pi over 2. It's pi over 2 plus k pi. And that's probably not an important distinction to him at this point, because he's only taken you so far up the math difficulty scale. And this is the more difficult way to look at it. If you're looking at it where the only thing we're looking at is from minus pi over 2 to pi over 2, then that's what you get. But tangent is just like all the other trig functions. It repeats. That's not it. Maybe that would be called the primary domain. I'm not even sure of that. I've never even heard that expression, but okay. So let's see. Did we have any questions about 2? Yes, we did. What did we say? I said I thought it was B. Or, yeah, I think I said I thought it was B. Let's have a look. Thank goodness I got one right. All right, now let's have a look at 3. And 3, I thought was, given what they gave for the answer on 1, I got to say it's E. And it is. All right, let's go on. Every now and then we'll check the answers. But mainly I want to progress. We move pretty slowly through these, and it might be me. I don't know. You feel like we're moving too slow or not?
No, I think it's okay.
Okay, good. I'm moving at whatever speed I think is necessary, and in other words, I don't have a goal in mind to get done 20 problems in an hour. All right. I know I'm going to draw a circle from the moment I see that. And I'm going to label everything they've given me as soon as possible. Then the measure of an angle that cuts an arc of length 6 centimeters measurement from here to there is you want to think about it for a moment before I say anything?
Sure. I don't know.
Okay. Well, let's examine a similar situation where you have a radius that cuts an arc of 360 degrees, right? So what is the circumference of that? What is the measurement of that arc? The arc that is the entire circumference.
360 degrees.
What's the measurement of the circumference? What's the formula for circumference?
Pi r squared.
That's area.
No, just pi r.
2 pi r. Think the derivative of pi r squared. And I don't think that's accidental, incidentally. The derivative of pi r squared is 2 pi r. Just like the derivative of the volume of a circle is the surface area of that circle. So we know that the circumference is 2 pi r, and that is a 360 degree angle. Well, which means what? Let me think for a second here. Well, let's tackle this a little differently. I'm going to suggest a way that's a little easier to solve. Okay?
Okay.
And that's back solving. Most of your tests are multiple choice, correct?
Most of it will be, and then we have a small short answer section.
All right. Well, it's worth back solving. Frequently, if your life depended on the problem, you would back solve. You would test all 5 answers. Okay? So I know that with a 360 degree angle, my circumference has to be 2 pi r. And they're telling us that the arc length is just double the radius. I love it. Let's approach this problem differently. Just occurred to me how we should approach this problem. Could have solved it that way, incidentally. If we had an unlimited amount of time, I might go through and solve it that way. But there's something more fundamental at play here that they're looking for. I didn't see it at first. If that angle is 1 radian, we have a radius of 3. What is the measurement of that arc?
Or let's see.
What does a radian mean? It means an angle that intercepts an arc that is the radius. That would have to be 3. That is the definition of radian. 1 radian is an angle that intercepts an arc that is equal to the radius. Really, really important concept in trig. Okay? Now, how many radians is that on the right?
2.
Okay. then the measure of the angle is 2 radians. Now, that certainly is not 120 degrees. 1 radian is not 60. 1 radian is about 57. In other words, 2, let me think for a moment. 2 pi radians has to equal 360 degrees. So 2 pi radians equals 180 degrees. I'm sorry. I mean 360 rather. Full way around the circle is 2 pi radians, which makes 1 radian, since pi is 3.1, yeah, it makes 1 radian. Well, let me use my calculator. I thought it was 57 degrees, but I might be wrong. 360 divided by 6.28 equals, 57 degrees. So a radian, 1 radian equals 57 degrees. So we know we have 2 radians by the definition. So we're looking for 114 degrees. That answer's not on there, but 2 is. C has to be the answer. In other words, they haven't told us whether they're going to give the answer in terms of radians or degrees. You'll notice that one's in degrees, that one's in degrees. That one is actually in radians, and that one's in radians, and that one's in radians. So there's only one correct answer, and it's 2 radians or 114 degrees. And the only number on there, C. This one I would bet my life that C is the answer. Maybe I shouldn't be so extreme to be betting my life, but I was pretty certain of that one. All right. This is really a more basic problem than the last one. They want to know what the measurement of that is. Based on that angle measurement and that radius. So, tell me what the circumference of this circle would be if I completed it. Let me complete the circle. What would the circumference of the green circle be? What's the general formula for circumference?
Equals 360 degrees.
Hold on.
Or no. So it'd be pi.
The general formula, it's not pi r squared. What is it?
2 pi r.
Okay. Now, what is that? We have everything here. What's the radius?
40.
It's 80 pi inches is the circumference of that full green circle. Now, what part of the green circle are we looking at?
Just that 20-degree part.
So what portion of this circumference do I take? In other words, that's a number. So what is this number? What am I going to multiply 80 pi by?
1/18.
Give me it as a ratio. That's correct, but I want it as 20 divided by 360. That's what portion of the circle we're looking at. So what do you get when you divide 80 pi by 18? Rounded to 2 decimal places. You have your calculator available?
Yeah. It takes a while to turn on though.
That's okay. Take 80 pi and divide it by 18. I can take a guess. Let's see, 18 goes into 80 almost 5 times, 15. I'm going to guess that or that. One of those two numbers.
Well, I don't know why this is taking so long.
Okay, I can do it, but in the future, have your calculator on and ready to go. Always in front of you.
Should be 13.96.
Okay, let's see. All right. And that's the way you do these problems normally, where they give you the angle and they give you the radius. Merely figure out, it's easy enough to figure out the circumference of the full circle. And then you're going to multiply it by whatever ratio of that full circle we're looking at. We're looking at 1/18. So whether I was doing this or I wanted to figure out the area of that, I would use the area formula and multiply that by 1/18. So all of these kind of problems, you have to make sure you look at it as a portion of a circle. Figure out the things of the circle and then multiply it by whatever ratio we're looking at. Whoops, hold on. I'm going to have to minimize this to get all the answers in there. All right, there we go. So give me the equation. Don't look at any of the answers, first of all. In other words, that's a tempting way to do it, but I want to make sure you know how to do this without it being multiple choice. You need to be able to know how to do this without it being multiple choice. And what it means is you're going to come up with a trig function equation. So figure out which trig function you're going to use, and then give me the equation starting with the trig function.
It'd be tangent, and then of 37.4 because that's the angle.
And let's make sure we specify degrees, because you can go real wrong if your calculator's in radians and you're talking about degrees, or vice versa. So what does that equal to?
X over 15.6.
Okay, so X is going to be what?
Just tangent of 37.4 times 15.6.
Which answer is that?
A.
Don't be too quick. Not A.
Oh, no, it's sine. E.
Okay. Now, you would hate to know how to do this problem and miss it because of that. That would be a true tragedy. It's one thing if you miss a problem because you don't know how to do it, but it's another altogether if you know how to do it and you miss it from just not reading the answer correctly enough. So be careful with that, especially on the ones that you know how to do it. Those are the ones that you most want to be careful on. All right, we'll draw us a lighthouse here. From the top of a 100-foot lighthouse. That's 100 foot right there. The angle of depression to a ship in the ocean is 9 degrees. So here's our ship in the ocean. And which angle is 9 degrees? The 1 or 2?
I think the 1.
Yes. That is what is 9 degrees. And that, because things are parallel, if I draw the ground here without curvature, then that's also 9 degrees, right? Because we have two parallel lines. That thing is parallel to that thing. So if the angle of depression is 9 degrees, then looking from the ship back to the lighthouse, the angle of inclination is 9 degrees. Okay. So how far is the ship from the base of the lighthouse? So they want to know that. Well, the only triangle we really are working with is this one there. So I definitely had to take that 9-degree angle of depression and turn it into a 9-degree angle in the triangle that we're trying to solve. So that was a necessary first step, I guess. I mean, I suppose you could have drawn a triangle like that and worked with that triangle and you'd get the same answer. As long as you put 100 over there, you're still trying to solve for x. But nonetheless, it's a little easier to think about when you're looking at from the ship back up to the lighthouse. So give me the equation that applies here. First of all, which trig function? That's always what you need first. So which trig function are you going to use?
It'd be tangent.
Okay, so give me the equation.
Tangent of 9 degrees equals 100 over x.
Solve that. What's x going to be equal? So, first of all, give it to me without your calculator and then come up with the number.
Tangent of 9
algebraically. What's the algebraic solution equal
to? That'd be...
It's 100 divided by the tan of 9 degrees. Whenever you see this situation where your variable is in the denominator, what you're going to do is multiply both sides by x and then divide both sides by tan of 9. So do it quickly in one step and you get that instantly without having to go through 2 steps of algebra. Okay? And a lot of times with these trig problems, or these are trig problems, a lot of times your variable ends up being in the denominator just because of the way the tangent function works. I suppose you could use the cotangent. That might actually be easier given the calculator that you have. Because notice the difference here. If I use the cotangent function, my variable ends up in the numerator, and all I have to do is multiply by 100. So 100 times the cotangent of 9 degrees is the answer. And it's just as easy in your Inspire to get cotangent as it is to get tangent. If you were working on a TI-84, would not be as easy. You would want to work in one of the 3 primary trig functions. But on that Inspire, it's just as easy to get cotangent as it is tangent. And the algebra is a little easier. But you do recognize the difference between these?
Yeah.
Okay, so what's 100 divided by tangent of 9?
Uh, 631.37.
Okay. The beauty of multiple choice is when you come up with an answer that matches it to the decimal point, you're pretty safe you got it right. If I look at that triangle, does that answer make sense?
Yeah.
Yeah. I mean, that's a 81-degree angle right there. So this triangle is not the way I drew it. This triangle is more like that. In other words, if that's the 9-degree angle and that's the 81-degree angle, it's a much longer stretched triangle. But notice it doesn't matter really. I didn't have to draw that to scale in order to solve the problem. Because all I had to do was draw it enough that I could figure out which trig function to use. And despite this easier method, using the cotangent, I would say stick with your tangent, sine and cosine. And just make sure you know how to handle that algebraically when the variable's in the denominator. Okay?
Okay.
All right.
I need to memorize my quadrants.
Well, they're pretty easy. Just go counterclockwise. That's 1, that's 2, that's 3, that's 4. Notice that I'm going counterclockwise, not clockwise.
I just need to memorize what they mean for each function.
Okay, well, I can help a lot with that also. There's a good little mnemonic to memorize. All students take calculus. The A means that all 6 trig functions are positive in the first quadrant. The S means that sine is the only trig function that's positive in the second quadrant. Now, of course, if sine is positive, then cosecant is also. So in reality, that's sine and cosecant. And in the third quadrant, the only thing that's positive is tangent, and of course, cotangent. We don't write the cotangent there because it spoils the mnemonics. The only thing you need to memorize is all students take calculus, but you need to know what that means. In other words, it means sine and cosecant are positive in the second quadrant. Okay? So, this is a classic trig problem. I want to teach you the way to do all of these. And first step is draw a triangle and label theta. Always, first step. Forget this for the moment. We'll get back to that. First step is to draw a triangle and label theta, or in this case, angle A. Now, dimension that triangle. That's the next step always. You can dimension 2 sides of that triangle. Tell me which ones they are. What's the opposite side?
So it'd be the 3 would be the opposite, and then 5 is the adjacent.
Not the
Or not adjacent, yeah, hypotenuse.
hypotenuse.
And that would mean 4
Those
was
are two sides that I can dimension based strictly on that. Now you can figure out the third side. What is it?
4.
Now you can figure out any trig function of A. So tell me what the cosine of A is.
3 over 5.
Nope.
Or not 3.
That's
No, 4 over 5.
4 over 5. Now, it's either positive or negative. That's what we have to answer next. They've got both 4 over 5s there. So we get that from the quadrant. It's
Well,
the
if
third quadrant. Is cosine positive or negative in the third quadrant?
positive,
What does it say in the third quadrant? T. Only tangent is positive. That means everything else is negative.
I thought only tangent was negative. Okay.
I'll tell you the positives. The A means all. So you know that in the first quadrant, all your trig functions are positive. So there's your key right there. It's not all negative, it's all positives. So we know cosine has to be negative in the third quadrant. So the answer is that one right there. And notice I didn't even address its plus or minus sign until I figured out the number. And I didn't need to even concern myself with which quadrant it was in until I figured out the number. I knew the number was 4/5, or the absolute value of the number was 4/5. So then it's real simple if you remember that all students take calculus, how to figure out what cosine has to be in the third quadrant. And notice that sine is also negative in the third quadrant. So they wouldn't even, no, that's not true. They do have to tell you it's in the third quadrant, because sine could also be negative in the fourth quadrant. Sine is positive in the first and second, and negative in the third and fourth. But you get all of that from all students takes calculus. That's all you have to memorize. The secret to trig is figuring out what to memorize and what not to memorize. You do not need to memorize everything. You only need to memorize enough such that you can figure out everything else. All right, let's see if we can do one more maybe here. Well, I don't know if we can do this one in 5 minutes or not. Well, let's draw their model. We have the unit circle. I know that has a radius of 1. And they're saying that it intersects the unit circle at -2/5 and that. Well, which quadrant is that? That 1, 2, 3, or 4?
B2.
Yeah, it's a ray. And is all I know is that that thing is -2/5, comma, √21/5. And that is theta. Right there. Not the short angle, but the angle in standard position, which is as measured from the x-axis counterclockwise. So, what else can I call these? I can call those x and y, but what else is x equal to? In the unit circle, x is the cosine of theta, and y is the sine of theta. Very important thing to remember. So they are saying that the cotangent, excuse me, sorry, hold on. This is a fairly tough problem, but they're saying that by giving us the coordinates of that point, then they're telling us that the cosine of theta is negative 2/5, and that the sine of theta is root 21 over 5. Okay? That's what they've told us with that information that I have circled up above. That's what that means, is the x-coordinate is always equal to the cosine of theta, and the y-coordinate is always equal to the sine of theta. Well, what's cotangent of theta? What's the trig identity for cotangent of theta in terms of sine and cosine? Tangent is what?
It'd be 21 over 5.
Hold on, give it to me in general terminology, because I haven't gotten to the math part yet. So I want to know, I want to make sure you know what it is. What is cotangent equal to? It's cosine over sine. That's what cotangent, that's the identity you have to memorize. You cannot get through trig without knowing these identities. Well, we know the cosine and we know the sine. So the cosine is minus 2 over 5. The sine is root 21 over 5. How do I solve that? And that's going to be our answer.
So it's just negative 2 over square root of 21.
Yeah. However, that's not likely to be an answer. Yeah, it is. Okay. That's actually a good thing, that they don't insist that you rationalize the denominator. Normally, it would be very rare to see an irrational denominator in a multiple choice question. It just is not common, because math kind of teaches you that you got to always have a rational denominator, but not with trig. And there's a reason that most trig teachers don't insist upon that. It's because trig is all about ratios. So you frequently have an irrational denominator in a ratio. They don't care, because if that's the cotangent, that means the tangent is root 21 over negative 2. In other words, it just depends on whether you're looking at the reciprocal or not as to whether that denominator is irrational or rational. So to spend a whole bunch of time rationalizing denominators doesn't make a lot of sense in trig. So particularly in the last 3 or 4 years, I have found that most of the trig teachers that I hear about are perfectly okay with you leaving a denominator as an irrational number. For example, this. Normally, I would tell everybody that you're never going to see a denominator like this. You're never going to see that, because that's an irrational denominator in a multiple choice. But with trig, you might. And that turned out to be the answer. So don't automatically rationalize. In other words, when you come up with an answer that's got an irrational denominator, look for that in the multiple choice before you go to the trouble. Because notice that if I rationalize that, now I've got something that doesn't show up anywhere. That's my answer, and that's not one of the 4 answers. So rationalizing it hurt. I end up getting an answer that's not on there. So don't automatically rationalize with trig. Especially now that I see your teacher puts that as the answer. That means he does not want you to rationalize these things. All right, we got through 9. We'll start on 10 tomorrow.
Okay.
Back, have a good rest of your day.
Oh, and then on that Wednesday, did you want me to do like 11:30 or just like 11:50-ish?
You pick. I've got it down as 11:50 to 12:50, but I knew we'd have a chance to talk about it, so whatever you want. What do you want?
Yeah, we can do 1150 to 1250.
Okay, does that work best for you?
Yeah, we can do that.
Okay. Tomorrow I will talk to you at 2.
Okay.
All right, bye-bye.